Hello, we're Group 6, consisting of members Roy, Braden, Sean, and Alex. Our project is on automatic code completion, and we're getting help from our friends Bert and Ernie to accomplish this. We're interested in automatic code completion to increase developer productivity, and to complete this task, we are using deep learning.
A few potential ethical issues regard the long-term database storage of developer information, such as Bert and Ernie. So the better ways of avoiding these ethical issues is storing the data we need for the models and then disregarding them after use.
We get inspiration from Pythia, which is a mature product in the database market and auto completion market. But other than that, we use the BERT, which is an end-to-end masking model, and we propose a brand new traversal, which is LCRS traversal, to transfer our AST to a set of sequence.
Our work can help producer to code faster. You can also reduce error when coding and reduce time spent on researching programming syntaxes.
Our project consists of 4 main parts, which are sequence traversal, BERT embedding, BERT, and Ernie. When BERT is going to help out with the end-to-end masking modeling, and Ernie is going to help out with the neural networks. And notably, we want to find a way to communicate with BERT and Ernie, and BERT only knows string and Ernie only knows number.
Because Bert and Ernie don't actually understand the raw data because it's stored in an AST format, we had to go through the process of traversing the AST and creating it into a set of sequences that Bert and Ernie could both understand.
After doing the AST traversal, we will obtain a set of string subsequence, so BERT can understand what is the sequence is. But Ernie has no idea what the sequence is, because Ernie can't figure it out what is the token in my sequence. That's why we need to use the BERT embedding. We can't use the numerical presentations because this is biased. We can't use the one-hot representation because we will lose all the connectivities. So we end up with using the skip-gram BERT embedding technology. By using the logistic regression and neural network, we get a set of integer subsequent and an embedding table to Ernie.
Now Ernie's happy. Through the use of the sequence list and the word embedding table, he finally has an input that he can understand. He's not going to use a regular neural network because there is no memory component, so he will not be able to process sequence data. As a result, he's using RNN, LSTM, and vanilla STM models. He's using the RNN to see the effects of short-term memory only, and then he's exploring the LSTM and the vanilla STM to see the effects of using long and short-term memory on predicting the next token. Next, we'll explore bidirectional model using BERT.
BERT model already found its success in much NLP applications, such as translations, sentiment analysis, and much more. To train the BERT model, we first train the tokenizer using the string sequence data. The tokenizer will embed sentence into tokens and understand their grammars. BERT is then pre-trained and fine-tuned with the same data that is embedded with the tokenizer. And when it's trained, it can produce a logits matrix that shows its prediction of a top n possible word for the sentence.
So now, BERT and Annie have done a lot of jobs, including RNN, LSTM, vanilla LSTM, and BERT. And for the evaluation process, we are going to use the top K accuracy classification. That's it. We figured out the probability and the likelihood of each candidate. And then we try to figure it out on the top K candidate. Could we find the true value of our target? If yes, return true. If no, return false. And that's what we are doing, and it looks great. For more detail, please look up our project final report.